In this video, we're going to find both the HCF and LCM of the same set of numbers. Here we have some examples. Find the HCF and the LCM of 24 and 120, and then 42 and then 48. Okay, so let's take the first one, 24 and 120. So the first thing we're going to do is to express 24 and 120 as products of prime factors and leave our answer in index form. So we have 24 is equal to 2 times 12, and 12 is 2 times 6, and this is 2 times 2 times 2 times 3. Now in index form, this is 2 raised to power 3 times 3 raised to power 1, and this is 24. Okay, now let's take the next one, which is 120. 120 is equal to 2 times 60. 60 is 2 times 30, and 30 is 2 times 15, and then finally 15 is 3 times 5. So 120 is 1, 2, 3, 2 raised to power 3 times 3 raised to power 1 times 5 raised to power 1. Okay, now how do we find the LCM? How do we find the LCM? And how do we find the HCF? Now the HCF, for a start, the HCF. To find the HCF, we look for the common prime factors, the prime factors that are common to both 24 and 120. So here we have 2, and then here we have 2, so the HCF will contain 2. Then here we have 2, and then here we have 2, the HCF will contain 2. And then here we have 2, and here we have 2, so the HCF will contain 2. And then finally here we have 3, and then here we have 3, the HCF will contain. Now this can also be seen from here, 2 raised to power 3 and 2 raised to power 3, and then 3 raised to power 1 and 3 raised to power 1 are the common prime factors. And this is simply 8 times 3, which is 24. Okay, now how do we find the LCM? LCM. The LCM is obtained by taking the product of the prime factors with the highest powers. Now we have to identify the prime factors. The prime factors are 2, 3, and 5. Now there's 2 here, there's 2 here. Which one has the highest power? Now both of them have the same thing, so we just pick one, 2 raised to power 3. Now there's 3 here, there's 3 here. Both of them are raised to power 1, so it's simply 3 raised to power 1. And then there's 5 raised to power 1 here. Okay, now therefore the LCM is 8 times 15. 8 times 15. 8 times 5 is 40, carry 4. 8 times 1 is 8, plus 4 is 12. So this is 120. Okay, now we take the next one, the HCF and LCM of 42 and 48. So first, 42 is equal to 2 times 2, trying to achieve 42 as a product of prime factors, and then this is 2 times 3 times 7. So this is simply 2 raised to power 1, 3 raised to power 1, 7 raised to power 1. 48 is 2 times 24, and 24 is 2 times 12, and 12 is 2 times 6, and finally this is 2 times 2 times 2 times 2 times 3. Now expressing 48 as a product of prime factors in index form will give us 1, 2, 3, 4. Now 2 is multiplying itself 4 times, so this is 2 raised to power 4, and then this is 3 raised to power 1. Okay, now the question is, how do we find the LCM and the HCF? First, let's take the HCF. The HCF is equal to the common prime factors. The prime factors that are common to both 42 and 48. So here we have 2, and then here we have 2. So the HCF will contain 2. And then here we have 3, and then here we have 3. So the HCF is simply 2 times 3, which is 6. These are the common prime factors. Then the LCM. In the case of the LCM, the prime factors are 2, 3, and 7. We have 2 and 3 here, so 2, 3, and 7. So of the 2's, which one has the highest power is 2 raised to power 4. So the LCM will contain 2 raised to power 4. Now of the 3's, which one has the highest power? They're the same, 3 raised to power 1. So this one will contain 3 raised to power 1. And then finally, of course, 7 raised to power 1. Okay, so this is equal to 3 times 7 is 21, and then 2 raised to power 4 is 16. 16 times 21 is 336.